In today's lessons, we're going to solve systems of linear equations in 3 variables. We're going to use the same techniques that we did when we solved systems with 2 variables, and we're just going to expand on them a little bit. So a solution to a system of equations with 3 variables is an ordered triple. So your x, then your y, then your z, which makes all of the equations true when substituted. So if I get an answer, I need to check it into all 3 equations to make sure it works out. Sometimes it might work for both the last 2 if you make a mistake, but not the third one. So you want to make sure you check your answers out. All right, so our goal is going to be, to begin with, to get 2 equations with the same 2 variables. So to do that, well, first on this one, you see I have this third equation. I numbered them 1, 2, 3. This third equation that has just 2 variables, the x and the z. So I'm going to use that as one of my equations with 2 variables. Now to get my other one, I'm going to use the addition elimination, and I'm going to add these 2 rows. You see it's set up pretty nicely because if I add these 2 rows together, the y's are going to eliminate, and that's what I want to happen. So I'm going to add 1, which is x plus y minus z equals 0, to number 2, which is 3x minus y plus z is equal to 4. And when I add them, I get 4x. Oh, and I get double duty here. And not only do my y's eliminate, but my z's eliminate also. And so I can get a 4 here. And I can actually finish up and divide by 4 on both sides and get that x is equal to 1. So there's one of my solutions. Then now I can go back to this equation that only has the 2 variables. If I place the x value of 1 in, I can figure out what z is equal to. So I'm going to substitute into equation 3, and I'm going to have then 5 times 1 plus z is equal to 7. So 5 plus z is 7, and z is equal to 2. And then once I find that, I can substitute in either one of these. It doesn't matter which one. So I think the top one looks a touch easier. So we'll put into number 1. I'm going to put a 1 in for the x. I don't know what y is. Minus z, which is 2, and I want that to be equal to 0. And you want to kind of keep double checking and make sure you did that right. So that's going to be y. 1 minus 2 is negative 1 is 0. So y is equal to 1. Now I want to check this. So if I write this as an ordered triple, it's going to be 1, x is 1, y is 1, and z is 2. So that's how I'd want to write my answer. I'm going to check it out. 1 plus 1 is 2. 2 minus 2 is 0. That checks. Put a 1 in here. That's 3 minus 1. That's 2. And 2 plus 2 is 4. That checks. 5 times 1 is 5, plus z is 2. So 5 plus 2 is 7, and that checks. So down on the bottom is a summary of what we would do. Now this was not a great, this wasn't a perfect example because everything eliminated. But you're going to use one pair of equations to eliminate one variable using the addition method, so addition elimination. Use a different pair of equations to eliminate the same variable. Once you do that, you should have 2 equations with 2 unknowns, and you're going to solve to find the variable values. So you're going to solve that. So now substitute to find the third variable value and give your answer in ordered triple form. So we'll pick up the next equation on the next video.